Welcome to The Explainer. If you've been paying attention to the news lately, or honestly just looking up at the night sky, you've probably noticed something massive happening. We are witnessing a historic shift right above our heads. I'm talking about the sheer, staggering scale of China's modern space presence. They're operating at a level that commands total global attention. But the real gap in our knowledge, the puzzle we've got to solve today, is how exactly did they do it? How do you go from being decades behind the curve to suddenly commanding the final frontier?
Okay, let's dive into this. In this explainer, we're going to reverse engineer their highly strategic master plan for space dominance. First, we'll look at the new space superpower. Then we'll walk through their step-by-step master plan, figure out what's fueling the space engine, examine how forced independence actually sparked innovation, and finally, we'll reveal the formula for the future.
Section 1. The new space superpower. To really wrap our heads around the magnitude of this strategy, we first need to establish exactly where China stands right now, and the reality is absolutely awe-inspiring.
Right now, today, China is officially one of the world's top 3 space powers. They aren't just participating on the sidelines, They are standing right alongside the United States and Russia. And remember, that is an incredibly exclusive tier of aerospace dominance that took the other 2 members nearly a century of intense competition to build. Just look at this highlight reel of recent jaw-dropping milestones. 1. They are actively operating the Tiangong space station, a permanent, independent orbital outpost. 2. They are executing flawless lunar sample return missions. And 3. They're already exploring Mars via the Tianwen-1 mission. Oh, and throw in their fully operational global Beidou navigation network while you're at it. It's a resume that is second to none. But it brings us right back to the central question of this explainer. How on earth did they catch up so systematically? Section 2. A step-by-step master plan. To decode this long-term strategy, we've actually got to hit the rewind button and look at the historical origins.
The story really kicks off back in the 1950s. Much like the US and the Soviets, China's space ambitions didn't exactly start with romantic dreams of walking on the moon. They grew directly out of military ballistic missile programs. They needed to build robust domestic engineering capabilities, quite literally from scratch. The pivotal figure in this era was a brilliant rocket scientist named Qian Xuesen. Fun fact, he actually helped pioneer the US space program before returning to China. Under his guidance, the foundational seeds of a future space superpower were officially planted.
And this brilliantly illustrates the core of their entire playbook, an incredibly disciplined, incremental progression. Just check out this timeline. Phase 1 in the 70s was just about getting satellites into orbit. Phase 2 in the 90s focused strictly on building reliable launch vehicles, basically the delivery trucks of the space industry. Once they had the rockets rocked down, Phase 3 in 2003 introduced human spaceflight. And that laid the vital groundwork for Phase 4 right now in the 2020s, space stations and deep lunar exploration. You see, they completely avoided the trap of trying to do everything all at once. By moving step by step, they dramatically reduced the risk and fed those hard-earned lessons straight from one phase into the next.
Section 3. Fueling the space engine. Because, let's be real, you don't execute a massive, multi-decade timeline like that without some serious mechanics powering the operation under the hood.
What's really fascinating here is the stark contrast in global space funding. In a lot of countries, space budgets are notoriously inconsistent, right? They fluctuate wildly with political cycles, changing administrations, public mood swings. But China took a radically different approach. They implemented decades of stable, centralized decision-making backed by guaranteed funding. Space wasn't treated as some isolated science project, it was hardwired directly into their broader, long-term national objectives.
But here's the catch. Stable funding is useless without the right minds to spend it. So they used that guaranteed capital to build a massive, unstoppable pipeline of STEM talent. We're talking about a dramatic expansion of engineering programs, heavy pushes in physics and math, and spinning up dedicated aerospace research institutes. They forged these deep university-industry partnerships, intentionally training thousands upon thousands of scientists specifically for strategic agencies like the China National Space Administration. They basically built a human engine designed to run for generations.
Section 4. Forced independence sparks innovation. Now we reach the catalyst. It's super interesting to see how geopolitical constraints actually accelerated their capabilities rather than slowing them down.
For years, strict technology restrictions from Western countries pretty much cut off China's access to advanced aerospace components. But in an ironic twist of fate, those restrictions acted as a massive catalyst. It pushed China toward absolute, uncompromising self-reliance. They simply had no choice but to build their own indigenous tech from the ground up. So they began heavily investing in designing their own rocket engines, their own satellites, highly advanced spacecraft electronics, and even their own deep space communications arrays.
The ultimate poster child for this forced self-reliance? The Beidou navigation satellite system. Denied the ability to rely on outside infrastructure, China independently developed Beidou as a complete, fully functioning global alternative to GPS. What started as just a strict domestic necessity evolved incredibly fast into a massive, globally utilized asset.
And man, this fierce, uncompromising independence yielded a string of truly historic milestones. In 2003, Yang Liwei flew aboard Shenzhou 5, making China the third country ever to independently send a human into orbit. Then came the Chang'e program, which completely pushed deep space boundaries with lunar orbiters, landers, and get this, an absolutely incredible world-first landing on the far side of the moon. And of course, the Tiangong space station, securing their independent long-term human presence up in orbit.
But here is the real secret to why this massive investment makes sense. The government doesn't just view space as a frontier for exploration. They view space as a crucial industrial multiplier. Pushing the limits of the cosmos creates intense, high-tech demand right back here on Earth. It drives leaps in advanced manufacturing, electronics, material science, artificial intelligence, telecommunications, the whole shebang. Every single dollar spent on rockets and rovers fundamentally levels up their domestic industry across the board.
Section 5. The formula for the future. We've reverse-engineered the pieces, so now let's pull it all together.
So, the absolutely crucial point to take away from this is, China's rise in space was not the result of a single lucky breakthrough. Plenty of countries attempt these wildly ambitious space projects, and they fail. China succeeded because they spent decades systematically building this exact scientific and industrial foundation. The core formula is clear. Long-term planning, combined with sustained, guaranteed funding, powered by a massive STEM talent pipeline, executed through incredibly disciplined incremental development and hardened by strict technological self-reliance.
Which brings us to a final, pretty provocative thought. With active plans right now for crewed lunar missions and rapidly expanding deep space exploration, we have to ask, what is this decades-long, unrelenting strategic focus going to yield next? As the new global race to the moon and beyond really starts heating up, this methodical formula is already fully in motion. The foundation is poured, the talent is in place, and the engines are quite literally lit. The only question left is, just how far will